Okay, good afternoon, everyone. This is Kitandwe Lambert, coming in from St. Mary's College, Kisubi. I'm going to take you through number 5, paper 1, analysis, stroke calculus. Treats a pond covers an area of 300 meters squared. A specimen of pond weed grows on the surface of the pond. At a time T days after the weed is first discovered, it covers an area of 8 meters squared. The area of the pond covered by the weed increases at a rate which is proportional to the square root of the area of the pond already covered by the weed. Initially, the area covered by the weed is 0.25 square meters and its rate of growth per day is 1 meter squared. Form a differential equation to show the relationship between A and T. So, from our information, we are told that the area, total area of the land is 300 meters squared, and after T days, the weed covers an area of 8 meters squared. So they have told us that the area of the pond covered by the weed increases at a rate which is proportional to the square root of the area of the pond already covered by the weed. So our dA dt is directly proportional to the square root of the area already covered by the weed. So what is next is to form a differential equation by introducing a constant k. But by the fact that they have told us that the area is increasing, that implies that our constant is a positive. If the area was decreasing, our constant would be a negative. But for this case, it is a positive. So the ADT is equal to k, our constant, then square root of A. That is our part 1, our differential equation. And then part 2, they're telling us to reduce to the nearest day the time taken for the pond's surface area to be completely covered by the weed. So we are going to straight away find a general solution to this equation from dA dt is equal to k square root of A. We shall begin by separating the variables. So we bring A on one side and T the other side. So dA all over square root of A is equal to k dt. Yeah? So what comes next is integrating both sides to get a general solution to this dE. So shall say integral of A to the power negative a half. I've made it a numerator. dA is equal to integral of k dt. So we just integrate by adding the power up and dividing by the new power. So it shall become A to the power negative a half plus 1, which is a half. So out of our new power, a half is equal to kt plus our constant c. And so our final equation will become 2a to the power a half is equal to kt plus c. So this is our general solution to the equation. So then we proceed to finding the particular equation of the, particular solution of the equation. So we first begin by taking initial conditions to get the constant c. So from our question, we have been told that initially the area of the pond covered by the width is 0.25 meters squared. So straight away at t is equal to 0, our A is equal to 0.25 meters squared. So we shall replace into our equation, becomes 0.25 to the power a half is equal to 0 times k is 0. So we remain with C. So that implies that our C is, so square root of 0.25 is 0.5 times 2, 1. So our equation again becomes 2a to the power a half is equal to kt plus 1. So that is, so we proceed to finding the k. So going back to the question, going back to the question, they have told us that initially the area covered by the width is 0.25 meters squared, and its rate of growth per day is 1 meter squared. So per day. So from people who do physics and chemistry, via the topic radioactivity, you can define your decay constant as the number of atoms that is disintegrating per unit time. So we can borrow from that the rate at which something changes per unit time is equal to the constant. So the rate of growth per day is 1 meter squared. So that implies that our K will be equal to 1. So our particular solution now becomes 2a to the power half is equal to t plus 1. Then now we can answer the question. Question say, reduce to the nearest day the time taken by for the pond surface area to be completely covered by the width. So that implies that our A will be 300 meters squared because the area covered, the total area of the land is 300. So when A is equal to 300, we don't know our time, which we are going to find. So it will imply that 2 into 300 to the power half is equal to t plus 1. Make t the subject, t is equal to 2 to the power, no, sorry, into 300 to the power half minus 1. So our t shall become 33.641 days. But the question says reduce to the nearest day. So that implies that we shall round off to the next day, judging by the 6 next to the decimal point. So that implies that our time shall become 34 days. So one thing to note is that once you're given such a question, and part 1 says form a differential equation, and it has only 3 marks, 2 marks, you can end on this here. But supposing a question comes and they've told you to form a differential equation and it's carrying 9 marks, yeah, you can go and check in past junior papers, there's that here, 9 marks. So you don't end only here for such a question, you proceed and find our, you proceed and find the K and find the C and end here. So yeah, I thank you all for listening to me. God bless you all. Wish you success.
Okay, before you leave, I think you've generated some bit of questions for yourself here.